Hello, welcome to Lead Programmer. Today we are doing the question removing stars from a string. So you are given a string and it contains stars. And we have given that in one operation we can choose a star and remove the closest character, which is not a star, to its left, as well as remove the star itself. So if we look at the example, then in one operation, if we consider this star, then we can remove this star and the non-star character to its left, which is the D. Similarly, if we have these two stars, then we can remove these two characters as well, leaving us with string which says Lecoe, and that's what we returned. So we have to return the strings after all stars have been removed. In the second example, we see that there are 5 stars and erase has 5 characters, which means that we remove all the characters, and hence the answer would be nothing. It would be an empty string. One thing to also note is the operation above can be performed on S is one of the constraints, which means that no illegal strings will be given to you. For example, if we had something like L star 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 ABC, this is an illegal string because here we have 3 stars, but we don't have 3 characters to its left that can be removed. So we don't have to deal with those scenarios based on the given constraints. Awesome. So let's look at another example here. So let's say we have this example right here. So we go from the left to right, we encounter a star, so we remove this pair over here. Therefore we get something like this. We have 2 stars, so we remove this over here. We get something like this. We have 3 stars, so we remove 3 characters, and hence we end up with a C. So you might notice that, okay, so it's pretty simple. Whenever we encounter a star, we just remove the previous character, which is not a star. And that might give us a hint of using some sort of data structure which can help us to easily remove remove the last element, right? We can probably have a string. So one quick idea would be, okay, let's have a string. So as we are going through the string over here, we went to we went to L, then we went to E, and then we encountered a star. Since we encountered 1 star, we remove the last element here, so we remove the E. Then we encounter a T, so we come to a D. We encounter a star, that means we remove the last element in the string. Then we encounter another star, which means we remove another character from the string. Then we encounter a C, so we add C. We have A, B, C, so we add A, B, C. Then we have 3 stars, so we remove 3 characters like this. So at the end we end up with a C. So this is one solution where we have a result string and we keep adding to it and removing to it as necessary. Another cute solution would be to use a data structure stack, because since we want to remove the last inserted element, which kind of gives us a hint of last in first out, so it kind of gives us a hint of a stack. So let's see how that would work. So let's say we have the same example. Here we first come to L, so we insert it onto the stack. We come to an E, so we insert that to the stack. We have a star, which means we pop from the stack. So we just pop the last element from the stack. Now we have a T, so we insert the T in the stack. Then we have 2 stars, so we pop twice. So we pop these 2 elements here. Then we have C, A, B, C. So let's insert all of them. And then we have 3 stars, so we pop the top 3 elements. And we end up with a C, and that's what the result is. So these two methods are valid. Both have the same time complexity and space complexity. So let's go into the code. So the code is pretty simple. I use the stack method. The string method that I described before is equally valid. So let's say we have a stack. We go through each and every character in the string, and we care uh, we care only about stars. So if we don't have a star, we just put it in the stack, and if we have a star, we just pop it from the stack. And at the end, we would have some elements in the stack, and all those elements would belong to the result. So we have a result string defined, and while the stack is not empty, we keep appending uh, to the result string and at the end we just return the result. So as described, the time complexity is the big O of n, since we go through all the characters once. The space complexity is also the big O of n, because we use a stack, and potentially the stack can have all the elements that are there in the string. So I hope you found this helpful. Thank you.